Hi, welcome to the lab. So, last video we implemented a string class, which basically holds a heap allocated string and a way to build them using a different class, which I'm calling string builder. So, what we also developed is a way to format a string, similarly like our debug log, but it returns this. So I also hid it behind a macro, but I think I will get rid of it. But you can say compose or the underlying function formatting format, give it some parameters, some arguments, sorry, and so basically they get turned to a string using a specialization of a formatter. So we have a class called formatter, knows how to format a value of a type. For example, this formatter knows how to format doubles. Implementation just appends it to the string builder. It gets passed. This is used for debug prints, also for the compose, the formatting format method. So and now, since we already had a formatter implementation for our syntax trees, so maybe I should begin by saying we're building a little parser that now knows how to parse registers, regular expressions. And so basically the syntax nodes already have a very basic formatter defined. So if I just switch to its definition, you see, so we have a syntax node for each kind of partial regular expression, and we have a little formatter which knows how to turn it into a string, how to append it to a string builder basically. And this we can now use our compose macro or the formatter to build a string out of it. So, and this video we're going to define some tests which test our parser, which I'm sure we'll find some bugs and we're going to fix them. But today I want to work on some tests, automated tests we run whenever I do. So, and for now, I'm just going to create a new class, I think. So it is a test for our library. So I'm just going to create a new C++ file, which I'm just going to call test. How do I want to build this? So I think maybe I'm already not sure how to do this. So let's introduce also a header, I suppose. The header just exposes a single function, and I'm planning to just call it visual tests. So, and our test file just includes our test.h. So let's include it in our build. Let's build it in the main executable for now. So this is all subject to change, of course, but just want a way to run them for now. So now I'm building them. Now I think we can just print something or include logging so that we can print something. So logging is now called formatting. I'm already forgetting. So the macro debug. Now the namespace formatting. I don't like this. I think I will move it later. But I think I'm just ignoring this for now. So let's just say hello sigil tests or something. Just to say hello. Let's always run this. So let's resurrect our old main class, main method. Let's just include test. Let's just run it. But let's always run it. So, and I think I'm just going to steal this method for now and put it in our test. So last time we built a little function which are just going to give a regex pattern, and it uses our parser to parse it, and it prints the underlying error if the parse was not successful or the AST, the abstract syntax tree of our underlying regex. So, and I think I need to put our parser? Regex parser. Does it work now? Oh, what is your problem? So I think I also need to include our syntax tree, since it doesn't know how to compose our syntax tree. Yeah, so it doesn't know the formatter for the regex for our syntax tree. So I think it's scope. Now it should build. Let's see. So how I'm going to do this. So I think I will just going to produce more. So I'm let's create a method. I'm going to call regex parser tests. Let's use plural name. So and those I'm going to call them here too. And whenever we want to add more tests, we're just adding functions here, just calling them in our overall test method. In our test entry point. So let's run it. Actually, what does it do? So it also our parser to parse thing, but should also print hello tests or something like this. Let's try it out. So yeah, so it prints our test entry point bug print, I suppose. So how we are doing this. So basically I would like to test using this function. So I think I would like to do something like this, but how do I fail? So let's for now. So I'm thinking, do I want to break tests? at the first failure. No, I think I'm just going to continue testing. So let's just say I would like that by I would like that. So I'm thinking I would like to compare so for example, if I'm parsing the regex, which is just a, I want to compare to a string which just prints our atom. In this case, all a. So does it make sense to formulate the tests in this shape? So just sketching something out. So for example, if I then concatenate two a's, concatenation, then I'm getting a concatenation of two a's. So, and I think I'm printing spaces. But then the lines get ridiculously long. How would it look like if I define a test for this? So I think this will work. So formatter of my IDE, but it looks so ugly. Maybe I will do this in a second step. So I'm just going to start like this. Maybe we will move the expected strings in a file, and maybe just hide it away from our source file. So let's do it. So first of all, I would like to introduce I'm not sure how to do this. So I would like to, of course, not only to compare strings, but in this case, let's just build it. So let's build a little method. Let's build a method that does just exactly this. So let's accept two or string-like thing. So, but here I have so I get a string and I think I know how to do this. So let's define this operation. Let's define this as a macro and just use the comparison operation. So let's not do a method, but expect equals. It takes in two values, and let's introduce a scope. So, and it just does nothing currently. So, but now, of course, I would like to say something like this. We compare, or let's evaluate those values once. So, or then let's call it something like, let's call it expected. No, I would like to do the actual value here and the expected always the last. And then we'll just, thanks. I think I'm forgetting some symbols, so now it formats correctly. So, and I'm just going to evaluate those values once. Expect. So, and then I'm just going to defer to the equality operator. So, if x not equal to y, I'm going to print an error. Yeah, I think I'm just going to print the now. So using our logging mechanism, we're just going to say expected equality. So, and then let's just print the actual as a raw. So let's just print the exception, the value we are just passing this expression. And then in the next line, we are printing the value it evaluates to. So actual is x. Then so expected equality of values actual, and so, and then I'm printing the expected expression, and then what it evaluates to. This is y, and that's it, I think. So of course now it formats to something horrible. And of course we need the equality operation, which we currently don't have. So let's do this. So let's implement equality operation for string and string view. Oh, but is there a way to reduce duplication? So our string view, let's start simple. I would like to operator to define the equality operator for string view, for two string views. And of course it doesn't change the state of our string view, and we can already define the equality operation. We can just define it as the negation of this equals to other. So, and I'm calling this other. So, and of course now I have to implement this. But should we all, so we can implicitly convert to string view. So I can always compare a string view to a C string, but I can't compare the other way around, but I think there's a line for it. So let's just implement this method. So let's see if our size is not equal to the size of the other string, then we can't be equal. So the simplest check. So now our sizes are the same, and then we can just say as an optimization. If we point to the same data, then we are equal. For example, if you copy one string view, then you have pointing to the same memory with the same size. And otherwise, these strings have the same length, but they are on different parts of memory. So then we have to look through our characters. So memcmp. Let's just mem compare. So I'm giving it two buffers and a size. It is equal, returns 0, but I'm not sure. So let's double check the implementation, the return values. 0 if the contents are equal. So this is what I want. So then I'm just going to give it data and other data and our size. So, and I think so let's use the so it returns a 0. So I could do not mem compare, but I would like to explicitly document what memcopy returns. So I'm going to so result is now an integer. Yeah, an integer, a constant integer, and it is 0. Well, let's just do it like this. Works. Could work. So this should be one of our methods we are going to define. So and now let's repeat this for strings. So our string class, where did I put it here? So let's just yoink this. So but string includes string view, so then I can just delegate string view. So if we are comparing string to a string view, we're just going to use the view method compared to a string view. So you can turn every string to a string view without allocation, and we're just using this operation to construct a read-only view of this memory of this class, and we're just comparing to the other. So, but what if we want to compare to strings? So if we're comparing a string to a string, I think we're just going to defer to other.view. Now let's do this. And if we are, in this case, we're just going to inverse. So I think this should be it. So if we are comparing a string to a string, we refer to this overload. This overload just delegates to string view, and this just delegates to this delegates to this. I think it should be fine. So now we have one implementation of the comparison. And now our test should compile. It does. So let's rebuild it to be sure, but the warning in my IDE went away, so okay, seems okay. So let's run it. What happens? So of course, I defined an invalid test, but I think it works. So the tests got run, they didn't mismatch. So, but for example, if I now define an invalid test, so this test doesn't work anymore. So then it prints that, well, that we had a mismatch. So and it says that this expression, which is this value at runtime, and this expression, which is this value at runtime, they are not the same. So you see it here. So I think, well, it is not a perfect test framework, but it shouldn't be. I just use it to test my tests, to test my parser. So now I would like to move this method closer to our test. Then let's build some more tests, I think. So what, first of all, let's kill our main implementation. So this is just debug code. I'm just going to run the tests. So let's open our parser and look inside what it actually should be able to parse already. Oh, I did this wrong. So we are supposed to parse alternatives, concatenation, postfix operators, and atoms. This test, back to our tests, and this just tests parsing atoms. So let's use another atom. So I know that we're not able to parse space. Let's confirm this. Yeah, just run it. I'm expecting a parse error because, yeah, I haven't implemented this. Yeah, so this is a little bit weird. So we're just comparing the result of our parser, and it says parse error. Yeah, so yeah, it's fine. So an okay error message. So let's keep this, and I know this as a test for later, I suppose. And I think we are also not currently able to parse escaped. Oh, what did I do? And we are not also not able to parse escaped characters. Parse error, yeah. So just a few cases which we have to implement later, and I think we can't do something like, I think common regex engines know how to give it a hexadecimal character, for example. So let's say let's use so no. I have not So I'm currently lagging, I'm sorry, ASCII table. Yeah, so I don't know the ASCII characters, the ASCII symbols by heart. So let's use 5e, so the circumflex symbol, then example, so hexadecimal 5e. This should be this symbol. So I know this symbol has special meaning in classes, but you should also be able to use it or you should also be able to use it just like this as a regular expression, I think. Let's confirm this regex test. Or is this a special character outside as well? So no, this is the position marker. Yeah. So let's just drop it. So let's keep this as a list what we are going to implement later. So, and of course, concatenations should also support everything we tested before. So, of course, you're just able to put two A's next to each other, and they should create a syntax node representing a concatenation. But you should also be able to do this with, for example, A space. So combination with a different symbol, a different regular expression. So and of course, those also should fail. So I'm commenting them out. So let's also add some tests for the alternative. So other tests. Let's use A or B, for example, and it could be an alternative of A and B. So this should work. So terminates, nates, but if I would say A or C, now the expected string should mismatch. Yeah, so perfect. So, but I think I'm not going to repeat those cases every time, just for the simple cases. So let's say A or space, A or n, and A or circumflex. So, and then, of course, we expect an alternative in every case. So then, of course, we should able to pass some postfix operators. So cleany, plus, and the optional operator. So let's check. Let's just start. So we expect a cleany of atom A, like this. So, but what happens, for example? So let's just put some. So I don't know, but my computer is a little bit lagging. So this operator we call positive clean. This one is called optional. let's just steal names from the right. But what happens if, for example, put multiple operators behind each other? So our parser should parse this. This should be a optional of positive clean of clean. So let's try it. Okay. Maybe let's leave a new line at the end of each print to separate the tests from the two consecutive tests from each other. So what's the problem? So I mistyped it. So here we have a extra quote. So I think my printer is just wrong. Yeah, see the problem. So for atoms, this is what I want, but our problem is that I don't want to print this for the postfix operator. Our test should correct. So one test is not working. So the nested postfix operator. So let's have a look. Oh, yeah, no, I think I know the problem. So we pass an atom. We're not. I see what the problem is. I see it. So I have to repeat this because postfix operators have the strongest precedence. So I have to pass an atom and every postfix operator which then comes. Yeah. So I think I know what to do. So let's introduce a local predicate, which I'm just calling to call postfix operator. And we're just going to redefine this switch. Yeah, so let's just think now I can just repeat this. So let's call this one result. Then we're just going to rewrite this part below. We can peek, and we are looking at a postfix operator. We can peek here. Then we consume the character. So then we can put the switch here, but advance. Since we know we're looking at a postfix operator, we then can consume the character and don't have to consume here. And then we're going to, so this case is impossible now, since we already checked that we're looking at a postfix operator, so this default case should never happen. So in this case, I'm just going to assert and crash print unreachable. And of course, I don't have, I'm not allowed to return here. I have to reassign result. And then of course we have to add the break statement. So, and now we're just going to return the result. So now, so I could also inline this. So I think I'm going to do that. Inline this method. Yeah. No, I don't do this. So, but I could inline this as well, but I'm just going to keep. And I don't have to recall peak. I think it is a little bit more clean, like here. Yes, so now, while we can peek and we're looking at the postfix operator, we're just consuming this and wrapping our atom we already passed. So if you see the next postfix operator, like here, so we saw an atom like this. Then we are consuming the next character and wrapping this expression as a postfix operator. Then we still can peek, and the next character is also a postfix operator. So I think this is a left fold. I think this will work here. So let's try it. So it works. Now our parser, we found one bug and already fixed it. So tests, those tests, I can rerun them every time I run the program. So I think I will just keep it in our main all the times. So I hate that line, also it is, I think it is Clang format, that it breaks my comments. I know I did this change, but I'm not going to fight with the format definition now, but I hate it. So, okay. But this is of course my mistake, since I specified the Clang format. So, but I think we're not able to pass expressions in parentheses. So let's add a test. Let's start simple. Let's just pass a in parentheses, expecting an atom. So it doesn't work. Expected atom, but got parentheses. So I know this is just printed, but later we should, of course, return it from our parser using an either type. Yeah, so, but I'm not going to sweat this now. I'm just considering happy cases. So, so let's say we have this atom. Where do we use this predicate? Okay, but I'm using it at two places. But I think I'm going to rename this to is primary expression, and I will also include the opening parentheses. So since let me explain what the problem is. Our parser sees a opening parentheses, and so our parser tries to pass an alternative. In the alternative case, it tries to pass a concatenation. The concatenation case, it tries to pass a postfix operator. The postfix case tries to pass an atom. in our atom case, looks at the character it sees, and it sees a parenthesis, but a parenthesis not only so checked if it was an atom, but we don't handle parentheses here. So this case is skipped. And then we print this and basically return an parse error here. So this is why we can't parse atoms. Let's change this. So this, let's rename this to isPrimaryExpression. Changing my mind all the time. So of course we check if our C is an opening parentheses, and later we will also add the opening bracket. So this character for character classes such as A to C. Like this is also a primary expression, what I'm calling atom. But this one is not really an atom, but there's a special handling. So for higher precedence parsing, I suppose. So since parentheses are used for grouping, you can override the precedence levels using this operation, basically. So this one will come later. I'm just dealing with open parentheses. So in this case, let's actually split this. I was too fast, I think, to rename it. So is atom, and we're just going to remove the parentheses from here, and a primary expression is an atom, of course, but also a parenthesis. So in this case, I'm using this predicate everywhere, so I'm using it here, and I'm using it here. So maybe I should also rename this. So it's a private method, doesn't really matter. So this, let's remove it, let's rename it parse primary. So a primary, I mean a simple expression. So basically the highest, a simple value, simple constant. So if we are looking at an atom, we use this case. And if we are seeing a opening parentheses, we are skipping this in the input, and then we need to see a expression. So parse expression, so which highest entry point, parse alternative, the lowest precedence level. We're just going to recursively call this method, and then we're expecting a closing parenthesis. So if we don't see closing parentheses, let's just deal with the happy case. We advance, since in this case we will return, and then we are after this expression. So in this case, we're going to return our expression. I see. So in this case, why do I? So I see. So I think I have to reassign, but I don't really. So let's peek here again. So let's not remember this value, but I need to remember it. So since after we advance, no, let's do it like this. So inlining this variable here, In this case, we're just going to remember our value. So it advances and returns the character we saw. So in this case, I will repeat. Since this expression doesn't change the state of our parser. So in this case, we don't need to remember this character since it was an opening parenthesis. So we're just advancing and discarding the character we have seen. And then we are calling parse alternative recursively, expecting a closing parenthesis at the end. So, and if we didn't this nor this, we have to repeat. But this should be fine since those predicates don't change the state. Okay. In this case, we are expected closing parentheses, but got. This is fine, so I think this should work. And of course, I have to propagate those arrows back to our parse entry point, but I'm not going to deal with this now. So let's see if our parser is now able to parse expressions in parentheses, and this works. So let's test some precedences. So now if I'm concatenating two values like here, we're just going to expect a concatenation. But what happens if I say something like this? So the alternative operator has the lowest precedence possible. So I'm expecting an alternative of our concatenation. And let's do closing parentheses. And I'm expecting two atoms here and here, and I'm expecting, of course, I have to change the payload. So this is what I'm expecting. Let's try this out. Okay, this works, but what happens, for example, if I move the OR operator, the alternative operator here? Now I'm again expecting an alternative on top level, but I'm structured differently. So the concatenation, I'm expecting it on the right hand side, so here. Okay. I don't know what this warning is about. Is within a recursive call chain, but why is this a problem? Don't get it. So what is your problem? I think I might forgot a closing parenthesis. So open, open, close, close. Ah, yeah, I see what I did here. But this must go. Oh, this. So now it should build. So the test should pass. It does. So let's combine those with parentheses. Override precedent. So in this case, let's repeat this case. So this is the lowest precedence, the OR operator. So A and B are grouped together, but if I put B or C in parentheses, we should basically get a concatenation on top level and a nested concatenation. So this goes here. I also have to move the parentheses outside. No? So what's the difference? What did I do wrong? I know. So here I'm expecting an alternative. So mistype the expected syntax node. Works. So let's do some more things. So let's work on extending our tests to support different kinds of atoms like space and escape sequences. So I'm just going to let's not call this one isAtom since we are not really sure. We can't be sure here since we can't decide. We see the first character such as a slash, we can't say for sure that atom. Let's call this can be atom. If I can change this correctly. Of course, also let's rename this can be primary expression. So now let's start working on how are we going to deal with this? So is there a possibility to, so I know there are some functions, maybe, so is there something like is visible? White space. Let's stare the ASCII table. So basically, I want to be able to handle every visible character. So starting at base, I want to support all of them for now. Yeah, just all of them. And of course, parentheses are handled different. So let's just include all of them for now and exclude parentheses. So but what happens if I'm adding a closing parenthesis? Oh, it is supported on top level, but this is a meta character. This has to be in combination with the closing class. Yeah. Okay, but this is, I didn't know that this is possible. So I think I can now optimize this. So let's see. I want to, but what? Let's double check what happens. Can I also put this top level? Oh, this is not allowed. But this is. Well, I don't really like this. Let's disallow this in our regex parser. So we're just going to allow, but also, so we don't need to, of course, we don't need to support every valid regex. We're just going to use a specialized, a subset, I think, just to specify characters. Of course, for our automatons. So I think I'm just going to ignore all of those. So, between 0 and 31. And 31. 31 is inclusive. Yeah, it is. So in this case, we are excluding. In this case, if our character is between 0 and 31, it cannot be an atom. Okay. So, and we don't need to support circumflex and dollar. Everything else is fine. So point is a meta character. But I think we can just include it here. So then everything up to 32 up to 39. I think I'm thinking I'm going to use character literal. So 31, yes, 31 is fine. I don't want to, but I think, can't I use Unicode escape sequence 1F? No? Plus plus? Oh, is it possible in C++? Yeah, so I am going to specify it like this. And in this case, we are space up to single quote. Escape it, of course. In this case, it can be an atom. So open parentheses. Let's document this. Open parentheses. Cannot be an atom. Closing parentheses. Can't be either. So let's just include this. Nice. So open parentheses, closing parentheses can't be. But can I use a star? No, it is a meta character. So this here. So then we have open parentheses up to plus. But what is it? Can I use plus? Or is it also a meta character? Also a meta. So up to plus, this can't be atom. So then minus, but I think we can use minus. Minus is fine. So minus is fine. So let's handle this. If C is minus, then it is an atom. But now the dot operator is, I think it's a meta character. So fine too. So minus up to dot. So now I can just include all of those. So from dot up to colon should be fine. Everything fine. Let's do up to capital Z. So in this case it is true for sure, but now so an opening parenthesis opening brace or opening bracket, using a closing bracket. I'm going to include this all. Yeah, everything fine. So up to tilde. Up to tilde, else not a valid atom. So I think now basically most of our cases should automatically work. So this case should work, this should work, this should also work. Sure. Sorry, I have to switch music, but advertisement was playing. Now the OR operator. I'm not allowed to include this as an atom. I see. This is of course an error, so and I can't just do naively up to I do the opening brace, so this should be fine. Yeah. I can naively include the bar operator. So opening brace fine. So for opening brace, and then I can do closing brace up to tilde fine, but we have one sneaky character in the middle. C is the bar operator, can't be an atom. So now those cases work. Of course, I can't pass escape sequences. So in this case, I think in this case it should pass this as a concatenation of slash and n. I think this is how our parser should work right now. Of course, I would like to group this. So how does actually regex work? No, it matches the character slash then n, not the regular expression. Matches those characters literally. So a line break, not matched, but this is matched, yeah. So should I do this? So let's join this behavior. So this is a concatenation of slash. So I have to escape it in C++ slash n. This is not a valid regex. So I'm expecting, no, but so I think this should work. So because I have to escape the slash in C++. So if I specify the regex slash n, it should be the concatenation of slash and n. Yeah, so now let's work on escape sequences. Then all of those cases, let's just start with simple escape sequence. Then all of those tests should work. We did them correctly. So in this case, enter this case, can be atom, since can be atom includes escape sequence. But so do I need to peek one character ahead now? I don't need to do this. So I'm consuming the character here, then I can peek ahead. If the next character, now if C is slash, then I have to handle escape sequences, otherwise I'm just going to return the atom. So escape sequence. We have the escape sequence, so then we can just peek. So let's peek, and if we see a slash, so a slash is a valid escape sequence, then let's also handle tab. No, I have to see T. Yeah, so. Well, what escape sequences are there? So B, I don't know what this does, but let's, so N, what is V? Vertical space character, is this even valid? So let's ignore all of those special cases for now. So character return and line feed, character return, line feed, and tab character. So let's just support them for now. So I have slash T. Oh, then all of my cases should work, but of course I can't handle this one for now. So let's start with those. Yeah, so I do express this differently. So here I'm consuming the character. If this character is an escape, a slash, and a escape sequence follows, then I have to special handle this. And otherwise, so I think I can structure this code a little different. Or can I? No, I can't. But in this case, if it is not a escape sequence, we're just going to return character as the original character. And in all of those cases, I'm going to basically override C to it. I'm going to override C with the next character and return this one. I'm consuming it, but I remember it as well. Now I have to decide, basically map this to a then I can do it a little bit better. So if I had maps implemented, I could use a map now, but I don't currently have a map implemented. So let's structure this differently. I'm going to define a function which I'm calling this one get escaped. I think I'm going to do this. It will return a character, and it will, so this one is the result character, and I'm giving it the character. So I think I'm going to define something like this, and then I can move this switch case in here. Of course, I don't peek here. I'm using the C. So, and in all of those cases, I'm going to assign the result. So in this case, so if we see a double slash, consider the second slash. So the first one is already, we get basically, we get the left character, second character of any escape sequence passed in. So in this case, our C is a slash, or it is a T or an R or an N. So we get this character, but we already know that we saw a slash before, so out of our context. So then we have to unescape basically. So let's call it unescape. Better name, of course. So in this case, we did unescape. Now let's copy this 4 times. And in this case, we return the tab character, the character return, and the line feed. In every other case, it was no escape sequence. So now C is a double slash. So, but we already peaked. So if we now peak, we see the next character. So either of those. So now I can say unescaped. And we're just going to call unescape and pass unescaped as a argument, a reference argument, and the next character, which is peak. So if we did unescape, we return the unescaped but in this case I have to advance. I see the difference. Makes sense. So this method, we abuse the fact that it doesn't write. Yeah. I think we can collapse a lot of things here. So I'm just going to reuse C. And we always just return an atom. But if we unescaped, we have to advance. So then I can move this code out of the condition, since it is the same in all cases. I think this should do the trick. So let's think through it. If we can be an atom, which includes escape sequence, we consume the first character. If this character is a escape sequence, we handle it, else we just return C. So then, if it was an escape sequence, we're trying to unescape it, write it into C. And we decide which escape sequence this was with the next character. So we peek the next character and pass it here. So, and we only assign to result if it was a valid escape sequence. So in this case, C gets overwritten. If it was not a valid escape sequence, we're just going to leave it as. So, and if it was an escape sequence, we have to consume the character. So then we advance, point to the next character, either case. So, and then, of course, we overwrote C, then we're just going to return it. Let's try it out. I think it should work. Aha, yeah, I see. So now the problem is that I'm printing. I see what the problem is. I'm printing those values incorrectly. How can I do this a little bit more beautiful? So, so basically I need, so in the code which prints our atom, so how is this? Let's peek. So our atom prints its underlying value. Our value is a character. I see. So of course I can't just use this value for printing. Basically of our unescape, but I'm where to put it. I would like to, because the escape and unescape should work symmetrically, I would like to define them next to each other. So, but do I want to put them in the parser? No, I don't think so. I'm thinking of putting them in a separate file. Class. Calling string utils. Oh. Language. Syntax? Maybe let's just keep it on the parser. So unescape and static bool escape. So, but escape, of course, returns a string u. Escape u, and it just gets a single character. No, I think I will do this the other way around. So, like this. So because both operations can fail, they escape and unescape are not total functions in my case. So then I'm just going to pose my implementation and create an inverse. Implement the inverse. So regex parser escape. So then I have to do the inverse. So so let's also switch on C. And now the inverse, I have to match those characters. We see a slash going to return slash slashes. And then we succeeded. So let's copy it 4 times. Default this here. So T, R, and N. And in this case, I'm just going like this. So now, of course, is unescape. Unescape is called here, but escape will be only used when printing. So let's go to our printer and let's extract value. Yeah, let's call it just C. So, and then we are just going to, do I have the parser in scope? No, but I can do this. So include sigil regex parser. So let's escape the underlying value, so expression.value. But if we initialize our string view with our character, so if we could unescape, we're printing the unescape value, the escape value, sorry. Else we're printing the raw. So and the raw value is expression.value. Oh, problem. Let's create a debug breakpoint here. So we have a lot of atoms. Comment out some test case. So where is this? So let's move this test case up so that our breakpoint actually hits the correct breakpoint. So let's see. Our expression contains a /n. So let's see what escape actually does. So we write the string view and return. So payload should now contain /n size 2. And in this case, I just return print this. Formats it. Yeah, should work. What's the problem? I think I have to double escape it as well. We are specifying the printed out version plus plus. So I could also use drawstring literals, but just liking to hurt myself, I suppose. So what's the problem? So double slash. Which test case is it? This one. So if I'm specifying slash, this is a slash, a backslash. I mean, the double backslash. So double backslash n. The escape backslash followed by an n. Yeah, I see. Unexpected. So all the universe, because I'm specifying the escape sequence using C++ semantics, my regular expression has a slightly different, or it has the same semantic basically as C++ escape sequence, but it's extremely hard to separate the universes, the escape universes basically in my head. So, but now it works properly. So the test was incorrect. So, but now we can also pass escape sequence. Well, primitive escape sequence. Let's also work on Unicode escape. Yeah, let's do it. So maybe I just want to commit first so that we have a clean working tree. So, but I can add those first separately. So quality operators between string and string view. Produce quality operators for strings and string. So, and I'm just going to add this as is. Or should I first of all so I could refactor this. So this was a bug in printing. I could do very small commits out of this. When printing ST nodes of Postfix, so it's a little bit too long, the commit move ST nodes Postfix. So let's then add Parser and Regex. So those are in sync. Okay, so we have changed multiple things. For example, we changed is going to commit everything together. So let's just describe it first and then work on a title. So our parser now supports simple escape sequences and looping regular expressions using parent. Our parser now supports simple escape sequences. /n/r and /t and looping regular expression in parentheses. I think this won't change at all. So, and of course nested simple escape sequences, looping of regular expressions in parentheses, and nested postfix operators. Such as a times plus. So, but how can we describe those three changes? So I could call it continue working on parser, but it is really, really unspecific. parse AU extend parser. It's really difficult to nail it. So this is I like this description, but I'm trying to come up with a simple. So let's not think too much. I described it in more detail in the description of the commit, of course. So let's not overcomplicate it. So how does our main actually look like? So let's see. We're just adding some tests, and some are commented out, but we will work on those now, I think, or maybe later. So produce tests for our regex parser. Okay, so I'm thinking if I should start working on the Unicode escape sequences, or if I just going to stop for now, since I'm getting a little headache. So let's see what we should do then. So basically, we can keep this as is, and if we fail to unescape here, and check if we see a U at the next character. In this case, we should peek 4 characters. Just peek 4 characters and parse it. I actually think this is not really smart, since our characters only be a single character. So we only support parsing single character, a single byte character. But this be 2 bytes. So I'm thinking just this format. So, but the main problem stays the same. So we have to check. So in this case we advance. In this case, so we advance and else we're trying to parse, but I would like what if I give it a string view? Maybe I can do something else. So if you're seeing a C is a escape sequence. Basically, we stripped the escape sequence already. We stripped it already from our inputs. So maybe we can do something like this. I'm thinking to change this to take in a character, a string view. This method. And in this case, it would have to return a string. Or else I must find a string view instance for every possible character. Which of course we could do. I won't do. So let's try it. So this one takes a string view. A string. And this one creates a string. That. Now do I also have to import this? Of course. So if we take in a string view, of course, now we can't just use peak. We have something a little bit more advanced. But now how much skip? So let's call this advanced. So now I construct a string view which points to our data. So starting from our current position, so our input and offset. So input. Does this operator always return a character? So no reference. Okay, fine. So then I can just calculate it myself. So we are pointing at the offset. And the length of this string view is input size minus offset, so how many characters we are remaining, but this can be way too large, but we also only want to peek ahead, let's see, 1 character in the case of a simple escape sequence, or 3 characters at max. So let's min for this. So, and in this case, this is the peaked string basically, a view, also constant. And I have to include min, but let's do it ourselves. We have no min. I could, or let's just include it for now and maybe replace this by our own implementation later. No, not define, include algorithm. What is this problem? I think I have to cast it to size. Do I have to cast the 3 to size as well? Yeah, so let's just force same types. So, and then I also define a local variable called skip. I'm also passing as a reference, and the peaked string. Oh, our size is unsigned. What's your problem? So this is signed. This is unsigned. Can't I just pass this to a size then? So now I can unescape this. But I have not only to advance single time, but much. But skip times basically. So this method tells the caller, how much characters it needs to skip. And it of course can also skip 0 characters. So this allows us to keep a similar structure than before. So let's see. So this returns a string. So if our view size we are empty, Let's add some helper methods. Empty, for example. How did I call it on the list? Make it consistent. Empty. Empty. Is empty and non-empty. Let's just going for. Is empty and non-empty. And let's also join it for. Nice. Well. So if our string is empty, then we did not unescape. Can't unescape. Else we have at least one character. So we can do the first X. So then we handle our basic case. But if we are seeing a new character, a U, have to do something else. So if we see a U, we have error. I think a Boolean is not sufficient. The return value. Don't know how to do it. So, of course, but I would like to find unescape and escape statically. But I need to communicate error case. I think they will move from our parser. So, getting a visitor. I think she wants to help me with our problem. You want to stay here? So she wants to keep us some company. So I can't see a thing. She's standing in front of my screen. You can stay here. Or can I easily inline it here? So how can I do this a little bit more easy? I want to simplify this since. So basically we have three possible outcomes. Error, or we could unescape, or it is a simple character. So it is no valid escape sequence. So this is an underflow, basically. Trying to unescape, but the unescape sequence is missing. In this case, did unescape, and we have also the case. No, this is an error case. We print a slash. So can we give a /k, for example? Token is incomplete. I see. So it is an error. So what does it do if I specify, for example, u? Can I then extend it to a valid? Oh, it is not supported. I want to support it, of course. Okay. So false is an error. Because if we saw a slash, we expect an escape sequence. I see. So this was actually wrong. So easy. So in this case, if we could not unescape, throw an exception. So in this case, we're going to return null pointer, print, for now, print, change this message. In this case, let's say invalid escape sequence. Escape. So then we advance skip times. Then we could, of course, unescape, so we're just writing. So in this case, valid escape sequence. In this case, we're just going to peek ahead 2 more characters. So if, let's say, we know that we have at least 1 character, but we now have to verify that the size is at least 3 characters. Character which we already consume, but we have to have 2 more characters and pass u5e, for example. So we can now peek in the next but 1 character. And we can also, but so if this is not the case, it is an invalid sequence. So we're just going to return false then. In this case, we can just build the result. So to build and now I have to verify, of course. So then let's another predicate, find it here. Is X character. But also we have lowercase and uppercase. So let's not overcomplicate it. Use external predicate. Let's just do it here. So yeah, well, let's just how should I call it? Call it 0. and C1. Now we have to verify it. If C0, so if we are a hex character, so I would like to do it as a predicate. Is hex character. So is hex. So if our C is between lowercase a and lowercase f, it is a hex character. If it is between uppercase f and uppercase, between uppercase a and uppercase f, then it is also a hex character. It is between the digit 0 and the digit 9, then also, and in all other cases, it is not a hex character. Okay, so now if C0 is not a hex character, we have not, it is not a valid escape sequence. I have validate the same with 1, and then I know both of them are valid hex characters. So now let's normalize. So 0, there should be a 2 lower. Where was this defined? Lower. Where is this method defined? Type lower. Okay. So now I only have to handle lowercase. Let's cast it to a char. Okay, so now I somehow exploit the property of, no, I can't. I don't care. So let's build something else. So now I have only lowercase character. Fine. So if C0 is between 0 and 9, or maybe let's do something like this. I would like to do something like something similar. I would like to do something like unhex, and I give it a digit. It returns me the value in SA. So this is the digit value, the result. I give it a digit, a letter, a character. So, and we assert, don't have to return anything. I assert that the character is hex. So now, So maybe it will just return the, I think I can compress my code. We return this. If is hex, if C is not hex, we return false. Else we normalize C and cast it to a character again. So now I can basically remove this code, and then I just have to return the result. So if C is now between 0 and 9, then I can return, then our result will be C minus 0. So C is a hex character, and we normalized it lowercase. So in this case, must be lowercase a and lowercase f. So I then can inline this. Don't need this hex anymore, except from unhex. So if not a not between this, can return false. We just invert this. In this case, we just don't fail. So and here I can then just do this. Result. I'm missing a semicolon here. So minus a. And in this case, we return true. Every of those cases we return true. So we could unhex our character. Stupid name, but it does the job. So now I can just I'm just going to define the first digit and the second digit. I'm just going to if not unhex 0 and give it the next digit in our sequence and could not unhex it error. And then we try to pass, or we try to read the next digit as a hex character. And so in this case, we have 2 digits. And we of course get the, I see already seen the problem. We see an A, we have to add 10 to it. So if we see a 0, it is of course the number value 0 and 9 the number value 9. But if we see an A, it has the number value 10. So if C is A, we calculate A minus A, which is 0. And then we have to add 10 to it. So this should be correct now. So now we have the value. So we have the digit values, individual digit values. We can just I think we can just assemble the final digit. So the digit value is 0 times 16, since we're dealing with hex, plus d1. And this digit is our result. So let's see if this actually works. But I have to also fix the escape method because it doesn't work anymore. So those are trivial cases. Just create a string view. Which gets easily converted to a string. So each of those cases will now allocate. So this expression won't allocate, but we assign it to a string. So the string gets implicitly converted, creates instances for all of those strings on the heap. But now, so now I think I can just toString everything here now. We have, since using the U escape sequence, we are now able to unescape every character. So escape is just a show method for string, for characters. So I think we can just do this. Escape. We'll just, let's just say unescape. Yeah, let's say unescape. So basically what I have to do now, let's special handle those cases. Else, it is neither of those cases, we're checking if our character is between space and what is the range of visible characters? It's tilde. If we are a visible character, just use this character to print it itself. Yeah, we can. In this case, we are a visible character. Then we just string view character. So we create a fake string view, just temporarily captures this argument by pointer. We just use this temporary string view, create a new string out of a single character, basically. So this will render a single character only. And if we are not a visible character, we will re-render it using the hexadecimal representation. So else so I can't print hex values, but can I somehow use it? So I can always create a local buffer. Let's just allocate 10 should be fine, 10 spaces at 10 characters. Then I can use snprintf in our buffer. How is the signature? So that's a format size of buffer and the format string. So the format string in my case so I think X is hexadecimal. Then I just print the character. So we actually look if snprintf failed. Now we have a hexadecimal character. So let's do the following. let's make this 11 characters and start by at one offset. We are rendering those as uppercase characters, and in the 0th buffer we write a U, lowercase u. But now size of I have to subtract 1 again. So now I basically do the same thing and create a new string view out of our local buffer count +1. So we temporary string view, which gets used to create a new string on the heap. Now this escape function can't fail anymore. Since it is defined, it is now a total function. So we can change its signature, not qstring, string. Yeah, so I'm changing it here as well. Then we can just return a string view, which of course gets converted to a string. We can simplify the code because we don't have to return a boolean everywhere. So in this case, we just return this and don't need to. So of course, this will cause an compile error here. So then we use the escape method. We always use the escape method. So we create an empty string. Oh, well, we don't need to. Just call our parser. We call our parser. Yeah, let's call it value. And now we just have to give it a character. And then this simplifies the code here as well. Nice. So I don't care that this one shadows. Okay, for me. So let's call it character. Let's call it rendered character. I mistyped this. Rendered character. So don't. This simplifies this code as well. So now it should compile again, or C++ should compile again. And I should be able to uncomment our tests here, since I would expect that everything works now as expected. So I broke basically all of our tests. I think I forgot to advance. So of course I forgot to set our advance field. So in all of those cases I have to advance, our caller has to advance one character. In this case, our caller has to advance the character. So we have basically U and 2 hex characters. So worked a little bit better. So we have a lot less error. We could not pass this. Did I calculate something wrong. So let's set a breakpoint here. So what? Let's move this on top to hit the breakpoint. So let's see what actually happens. So we construct a peaked string. I would expect that it starts with this string. Yeah, of course, 25e. So because we limit to 3 characters, but yeah, also might be able to, the input is all, we limit it, of course, to the remaining characters. So, but this is correct. So now we jump into unescape. We are not empty, and we see a new. So we have at least 3 characters. Let's look what un does. So unhex. Our character is a 5. So it, I see. So, see what the problem is. I have to. So that was dumb, of course. Have to something like this. So if we're not between this or this or this, then return false. Did this already fix our problem? Let's see. So this should not skip. And 5 to lower should be 5. We are between 0 and 9. So we decode this character and go. So we could read the first character, the second one, 14, correct. We should advance 3 characters. We also decode it as the correct symbol, the correct character. We should skip 3 characters. So, and unescape return true, so we give this. Now we return a circumflex. Now our test should work. So let's retest. We run everything. Works perfect. Hexadecimal escape sequences are working. Nice. So, I think we did some great progress today. We found a way to test our parser and also used our parser. We ruled out some bugs in our parser and extended it, and also extended our tests. Basically, now that our test framework works, yeah, there's some great progress bringing our parser a lot closer to done. Of course, we still need to parse character classes, but yeah, we did some great progress today. So let's actually commit our change. So I added So I added, how do we want to write this? Is empty and non-empty, predicate methods on for a string and string view. So what did we do? So this is all our code which we changed. Just put it together. This code got simplified. But I think we everything. So make parser understand hex. How are they called? Hex escape sequences. In the shape of UX. Perfect. So I think I did everything I wanted to do today. Yeah, I think next time we are going to keep working on our parser until it parses regular expressions. Yeah, but nice progress today. Thanks for watching. See you next time. Bye.